Hello and welcome back to my channel. Today we're going to be doing related rates day 3. We're going to start with a cone. So water runs out of a conical tank at a constant rate of 2 cubic feet per minute. The radius of the top of the tank is 6 feet and the height of the tank is 12 feet. How fast is the water level sinking when the water is 5 feet deep? So the first thing we're going to do is draw a cone. So we have something that looks like this. I know water is running out of this at 2 feet cubed per minute. It's a cubic feet per minute, so I know that this is going to be a volume. It's also a rate of change, so this is going to be a dV over dt. It's also going to be negative because it's water leaving, so our volume of water is getting smaller. It tells us the radius of the top of the tank. So if I put something here, this would be 6 feet. And the height of the entire tank is also 6 feet. Oh, sorry, the height is 12 feet. How fast is the water level sinking when the water is 5 feet deep? So we have our water here, and this water level is 5 feet. So we have a couple different things to look at here. The first thing that we need to do is we need to find the equation for the volume of a cone. So the volume of a cone is 1/3 pi r squared times our height. So one of the things that we need to kind of keep in mind here is they really didn't give us that much information. They gave us a volume's rate of change, but not the volume. They gave us the dimensions of the tank, and they gave us the height of the water. So we don't know what the radius of the water is. We could figure it out if we want to because this cone is going to be consistent. So when my height decreases, my radius is going to decrease relative to that. But it didn't give us a rate of change for the height because that's what we are solving for. And it didn't give us the radius is changing. And because that radius is changing size, the rate the radius is changing is going to also be a value that exists. So if I were to take the derivative of this function as is, I would have to use product rule because there are two variables right here being multiplied. These are both constants, so we can kind of ignore them, but keep them in mind. We just don't have to worry about doing a special derivative for them. So we're going to have some extra things here that we don't necessarily want. So when we look at this cone, one of the things that we're going to notice is if I compare the radius to the height, it makes this shape. And if I were to pull that out with the side of the cone, it makes a right triangle. And it doesn't matter where our height is later, we're always going to get a right triangle. And more specifically, these right triangles will have the same base angle down here. And it'll always be a right triangle. So if this angle is the same every time, this angle is the same every time, then this angle has to be the same every time, which means these two triangles are similar. So we can set up a proportion where they are equal to each other. So if I know that the radius is this one and the height is this one, and I also know the tank's radius is 6 the tank's height is 12, I can set up a proportion between our radius over our height equaling 6 over 12. I can set up this proportion as radius over height or height over radius. It doesn't matter. But what I want to do is I want to try to simplify. So 6 over 12 is the same thing as 1/2. And I'm going to multiply by an h. So I get 1/2 h. So if I half the height, that gives me the radius. And that makes sense based off of that relationship between 6 and 12. The thing that we are solving for is h. So I want to get r by itself, which we have here. And we are going to take this value and substitute it in to our volume equation. Because radius and height have a relationship together, we can now use height instead of radius. So 1/3 pi r squared h. Well, r in this case is 1/2 times the height. I'm going to go ahead and simplify this. So this is our volume is equal to 1/3 times pi is just pi over 3. We still have this h over here. So h squared is just h squared, and we have 1/2 squared. Well, 1/2 times 1/2 is 1/4. So if I multiply these together, we get volume is equal to pi over 12 times h cubed. I have now gotten rid of my product rule, and I've gotten rid of an entire variable. So if I take the derivative of this, we have dv over dt is equal to 3 times pi over 12 is going to be pi over 4 h squared dh over dt. We know what dv over dt is. It's -2. We know we have pi over 4. H is 5. And dh over dt is what we are solving for. The only thing that I'm going to do to make it a little bit easier on myself is I'm going to multiply both sides by 4, so that way I don't have this fraction here. So we have -8 is equal to pi, 25 pi, or pi times 25, dh over dt. So I'm going to divide both sides by 25 pi. So I have -8 divided by 25. 25 pi. This is dh over dt. So the height, or the water level, is sinking at a rate of, we don't want the negative because we already said sinking, 8 over 25 pi. Our height is in feet, and our volume was feet cubed per minute, so it's going to be feet per minute when the water is 5 feet deep. We only need to put this in a calculator if it is a multiple choice question, which is on the calculator portion, or it is calculator active, then we would want to put this in the calculator. Once again, we want to remind ourselves, if we divide by 25 pi, we either want to say -8 divided by, and in parentheses 25 pi, or -8 divided by 25 divided by pi.